Okay, so just to summarize what we've just done here, the question, okay, so the question is saying, the setup is just saying, this is a speed time graph describing a cyclist moving along a straight road for 7 seconds. In other words, we're monitoring and recording what the speed was at any point in time during the period of time of the first for 7 seconds. So it looks, by looking at the graph, that the speed increased and increased and increased until it reached the maximum of 5 meters per second, and it reached that maximum after 3 seconds. And then it looks like it just stayed at that speed for the rest of the 7 seconds. In other words, for 4 seconds after that. The first question is asking, work out the acceleration for the first 3 seconds. Now, I've avoided using this formula, which you can see there now anyway, but let's think about it in terms of sort of first principles. What is acceleration? Well, it's just, we know it's when the speed is increasing, but maybe it's better to say when the velocity is increasing. Well, for now, I'll just say that it's the rate of change of velocity rather than the rate of change of speed. We won't talk about why that is at the moment, but we say it's a change in velocity. So if the velocity is changing, it's accelerating. And it's how quickly the velocity is changing is how high the acceleration is. So, and it doesn't matter, it's unrelated to what the speed is at the time, really. So the speed could be really high, but it might be increasing slowly, then the acceleration would be low. You could have a high speed with a low acceleration. You could also have a low speed or low velocity with a high acceleration. If it's starting off at 0 and it gets to only 2 meters per second, but it did it in a really short time, then we could say it's got a high acceleration. So looking at this graph carefully, we can see that it's changed from 2 to 5, which means a change of the increase in velocity is 3 meters per second, and the time taken was 3 seconds. So what acceleration is really is how much the velocity changes each second. If it changed by 3 meters per second in 3 seconds, then each second it must have changed by 1 meters per second. And you can show this visually on the graph. At 1 second, it would have got to 3. At 2 seconds, it would have got to 4. And at 3 seconds, you can see it's at 5. So if it's increased by 1 meter per second, then what we could do is we could write it as 1 meters per second, because that's what we're saying here. It's increased by 1 meters per second in each second, so per second again. But you can also think about these units, as I've talked about before, as just like as letters, like in algebra. So meters per second, so m divided by s, and then divided by s again. How do we do that? Well, it's the same as saying m over s times 1 over s, which is m over s squared. And that's why the unit is and so let's just explain this minus 2. So m over s squared is obviously the same as m times 1 over s squared. Well, 1 over s squared is the same as s to the minus 2, so it's the same as m times s to the minus 2. Okay, this is from the topic of indices or powers, but essentially when we do this, minus is like saying 1 divided by. So for example, if I did, let's do over here, like x to the minus 1 is the same as x to the 1. It's the same as 1 over x to the 1. X to the minus 2 is the same as 1 over x to the 2, and so on. That's all I've done here. So the answer there is 1. But in terms of actually what the formula is, now we've broken it down, thought about it, really it's the change in velocity divided by the change in time, and that might be the change in velocity can be calculated by the final velocity, which is 5, minus the initial velocity, which is 2. So that would make it 3 in this case. But the general formula would be the final velocity minus the initial velocity divided by the time taken to change that velocity. That would be the formula. Okay. All right, I'll stop that there.